Got a little bit of a rant coming here.
I'm having difficulty
Oh, this
scanning the
classic
object.
scene.
It appears to be approximately 200 million kilometers in diameter.
That's a bit more than Earth's orbit. A full Dyson sphere. So they're enclosing a star at a distance where temperature is Earth-like and similar solar flux. This part is surprisingly grounded for sci-fi.
That's nearly as large as the
Yeah. Okay, notice how he says surprisingly grounded for sci-fi.
Earth's orbit around the sun.
So that figures out to over 500 million Earth surface areas for this thing.
Why didn't we detect this before now? The object's enormous mass is causing a great deal of gravimetric interference.
No, a Dyson
And this is what ticks me off about academics. One, yes, this is a scientific thing, but in order to make it, you're not going to be restricted to our level of physics.
sphere consists of the stellar mass plus the massive structural mass of the sphere itself. You're not missing that gravitationally. It would be obvious by orbital mechanics and infrared signature.
Not if it's oh, I'll let it keep going, then I'm gonna rant.
You search for these in real life,
That might have prevented our sensors from detecting it before we dropped out of warp. Mr. Data, could this be a Dyson sphere?
more like a Dyson Sphere's final form. Dyson's original idea was a swarm of satellites. A solid sphere has no stable orbit around the star. Any offset, you're gonna have a collision. Plus, the thing's over 1,000 Earth's masses. Gravity from the star is pulling it in, and centrifugal support does not work uniformly for a shell. The material strength required is orders of magnitude beyond steel and even other exotic sci-fi materials that you see in Star Trek.
In the 20th century, a physicist called Freeman Dyson postulated the theory that an enormous hollow sphere could be constructed around a star. This would have the advantage of harnessing all the radiant energy of that star.
That's correct, or about 10 trillion times current human energy use. That's a lot of nuclear power plants. However, if you capture all that energy, you must also radiate all that energy. Otherwise, the sphere is going to cook itself.
Any population living on the interior surface would have virtually inexhaustible sources of power.
Power is not going to be your limiting factor. Heat rejection and structure are. And if you're living on the inner surface, in a hollow sphere, gravity is going to cancel out, so they're going to be in 0G. Unless you rotate the thing with a period of a year, but that's going to create enormous structural stress.
Are you saying you think there are people living in there? Possibly a great number of people, Commander. The interior surface area of a sphere this size is the equivalent of more than 250 million Class M planets.
That's reasonably close. But area is not your problem. Resource distribution, energy routing, and heat management are far bigger problems in space. And in typical Star Trek fashion, they never bring this up again.
Sensors?
Okay. The rant commences. First off, the structural issues that he pointed out. Presumably, this Dyson sphere was built by a civilization that is so much more advanced than what we see in Star Trek, within the Federation at least. They would no doubt have something like gravitational manipulation, which something that Starfleet has, just on a massive scale. Manipulating gravity so that you can build your Dyson sphere out of something that isn't adamantium and unobtainium makes things plausible. You can still power those systems because you're getting a shit pile of power out of the sun. But that's going to alter the gravity mass of, or the observable gravity of the shell. Two, you have to motion lock that shell with the star as it moves through the universe. So that's another something that you might be offsetting the gravitational source or the gravitational signature with. And three, you got to keep people on the inside of the, or on the surface inside. So that's a third layer of gravitational manipulation. So very well you could cloak or mask the entire mass of the star below something where Starfleet sensors would pick it up as, hey, there's a star here. Secondly, the heat rejection. You don't necessarily have to radiate the heat if you have some form of technology that you can efficiently direct the heat wherever you want it to. And then what you do is a little trick known as nucleosynthesis. So if you're a student of nuclear fusion, you know that stars generally take hydrogen and crush them under immense pressure until they fuse into helium, releasing energy. That's how stars work. And they can keep crushing elements, to release energy. It's usually less and less energy with every iteration as nuclear binding power or binding energy increases. So, like, you can, I think fusion, the basic fusion we know of goes up to just before iron. Once a star starts trying to fuse iron, it starts going into negative energy generation. It takes more energy to fuse atoms into iron than is generated by previous fusion events. So you can fuse up to, I think, carbon, oxygen, nitrogen are all in that range. Hydrogen and helium, of course. But once you get to iron, it starts taking more energy to fuse them than you can get out. So if I was running a Dyson Sphere civilization, I would be dropping my heat rejection into trying to fuse iron and even heavier elements over trying to radiate all that energy. Because then you could be constantly generating more material, and you have the added benefit of you don't have to reject all this energy and allow your Dyson sphere to be detected through infrared. I think I'm going to do, it's now in my list of things to do outside of streaming. I'm going to start making, or try to start making videos once I figure out how to do that out. And I'll post them up on YouTube.